You know what bothers me more than any unsolved equation in physics? It is the silence, the absolute, total, deafening silence from out there. We have got a galaxy with 400 billion stars in it, and most of those stars have planets going around them. And a whole lot of those planets sit in just the right zone to have liquid water and the kind of chemistry that leads to life. And the universe has been running for about 13 billion years, which is a very long time. Long enough for life to have started, evolved, built cities, figured out physics, and sent signals across space 10,000 times over before our sun even formed. So where is everybody? That question, if you actually sit down and think about it carefully, does not just feel like idle curiosity. It starts to feel like one of the most important scientific questions ever asked. And I want to argue something specific here. I want to argue that gravity itself, the very same gravity that holds you in your chair right now, gives us a profound clue about why advanced civilizations either cannot exist in the way we imagine, or if they do, they are so deeply constrained by physics that watching us would be the last thing on their minds. Let me start with something that seems completely unrelated, a cannonball. Suppose I fire a cannonball straight up from the surface of the Earth. It goes up, slows down, and eventually comes back down. That is obvious, but if I fire it faster, it goes higher before coming down. And if I keep increasing the speed, eventually I hit a magic number about 11 kilometers per second, where the cannonball just barely escapes the Earth entirely. It never comes back. That number is the escape velocity. Now here is the interesting thing. That same calculation done with slightly different numbers gives you the escape velocity from the solar system, from the galaxy, from galaxy clusters. Every bound gravitational system has a threshold speed you need to exceed if you want to leave it. And space is extraordinarily large, which means the energy you need to cross it is also extraordinarily large. Now let me give you a sense of just how much energy we are talking about. Our nearest neighboring star system is Alpha Centauri, about 4 light years away. If you wanted to send even a small probe, say something the mass of a car, across that distance in a reasonable time, maybe 100 years, you would need to accelerate it to about 4% of the speed of light. The kinetic energy required for that is roughly equivalent to the total energy output of every nuclear power plant on Earth, running continuously for about 100,000 years. And that is just for a car-sized probe going to the nearest star. For a cruise ship, or for travel anywhere interesting in the galaxy, the numbers get so astronomical that they challenge everything we intuitively believe about what an advanced civilization could accomplish. But wait, you might say, what about a really advanced civilization? What if they have been around for 1 million years and figured out energy sources we cannot imagine? That is a fair point, and physicists have actually tried to categorize this. There is a framework called the Kardashev Scale, named after a Soviet astronomer, and it ranks civilizations by how much energy they can harness. A Type 1 civilization uses all the energy available on its home planet, something like 10 to the 16th watts. A Type 2 civilization has learned to harness the full output of its star, something like 10 to the 26 watts. A Type 3 civilization harnesses the entire energy output of its galaxy, around 10 to the 36 watts. We right now are sitting at about 10 to the 13 watts. We are not even a Type 1 yet. Here is what gravity has to say about the feasibility of becoming Type 2 or Type 3. Your star, sitting there fusing hydrogen into helium, is held together by gravity. The pressure inside a star is so immense and the temperature is so extreme because gravity has compressed an enormous amount of hydrogen into a very small space. The energy that comes out is a byproduct of that gravitational compression. So the energy output of a star is fundamentally set by gravity and nuclear physics together. You cannot turn up the dial. You cannot make the sun produce more energy than its gravitational mass dictates. And to actually collect and use all of that energy, you would need to build a structure around the star, what theorists call a Dyson sphere. Something with a radius of roughly the Earth-Sun distance, constructed from an amount of material that simply does not exist in nearby space. You would have to disassemble several planets, distribute the mass into a perfect shell, and do this without the shell itself collapsing inward under its own gravity or getting torn apart by tidal forces. The engineering constraints imposed by gravity alone make this spectacularly difficult. But let us say they figured it out somehow. Let us say there is a civilization 1 billion years old, and they built a Dyson sphere around their star. What can they do with all that energy? Well, they still cannot outrun the speed of light. That is not a technology problem. That is a fact about the geometry of space-time itself. Information cannot travel faster than light, and neither can matter with mass. So even if you have the energy output of a star at your disposal, crossing the galaxy, which is 100,000 light years across, still takes a minimum of 100,000 years one way. That is not a trip you plan. That is a commitment of civilizational resources over geological time scales. And gravity keeps making this worse, not better, because there is no clever shortcut. Wormholes are mathematically permitted by general relativity, but to hold one open, you need exotic matter with negative energy density, something we have no evidence exists in the universe in usable quantities. And gravity itself fights to close any wormhole you try to stabilize. Now, here's where I want to sharpen the argument about silence. If advanced civilizations are out there in large numbers, and some of them are genuinely millions of years ahead of us in technology, they would have had time to spread across the galaxy many times over, even at sublight speeds. A civilization expanding at just 1% of the speed of light, taking thousands of years to hop between stars, could still colonize the entire Milky Way in about 10 million years. The galaxy is roughly 13 billion years old. So the question is not just where are the signals. The question is, where are they physically? Why has no civilization sent even a self-replicating probe that has been quietly copying itself from star system to star system for the last billion years? Where is the evidence? Anywhere in our solar system or nearby space of past or present engineering by another species? There is nothing. And gravity has a lot to do with why. Think about what it takes to launch anything significant into interstellar space. The escape velocity from the surface of an Earth-like planet is about 11 kilometers per second. The escape velocity from the solar system, starting from Earth orbit, is about 42 kilometers per second. These numbers mean that every kilogram you want to send to another star requires enormous energy expenditure just to get it out of the gravitational well of your own home system. Gravity is not an enemy you defeat with cleverness. It is a constant tax on every gram of material and every joule of energy you want to move around the cosmos. And the deeper you start in a gravity well, the higher that tax is. Now, here is a specific piece of physics that I think is underappreciated in this conversation. There is something called the rocket equation, and it was figured out by a Russian school teacher named Tsiolkovsky in the early 20th century. It says that the amount of fuel you need to achieve a given velocity grows exponentially with that velocity, not linearly, not quadratically, but exponentially. So, if reaching 1% of light speed requires carrying, say, 10 times your payload mass in fuel, then reaching 2% of light speed requires roughly 100 times your payload mass in fuel. Reaching 10% of light speed requires staggering fuel fractions that make the whole enterprise almost absurd, unless you have some truly exotic propulsion system. And gravity is the thing sitting underneath all of this because fuel itself has mass, and mass is what gravity acts on. Chemical rockets, which is what we use today, are fantastically inefficient for interstellar travel because the energy stored in chemical bonds is tiny compared to what you need. Even nuclear rockets using fission or fusion reactions are far better, but still face the exponential wall of the rocket equation. The only plausible escape from this wall in terms of known physics is something like a laser sail, where you accelerate a very thin, very light object using a focused beam of light from a fixed installation. The Breakthrough Starshot project has actually studied this seriously, aiming to send gram-scale probes to Alpha Centauri at roughly 20% of light speed using a large laser array. But those probes cannot slow down at the destination without a second laser array there waiting for them. And the communication round trip at light speed would still take 8 years per exchange. This is the universe gravity and relativity have conspired to build, where even the most optimistic, realistic scenarios for interstellar travel are extraordinarily costly and slow. So I want to put a different kind of hypothesis on the table. What if the silence is not a mystery at all, but a prediction? What if gravity, combined with the fixed speed of light, makes genuine interstellar civilization not just difficult, but so energy expensive and time-consuming that it simply does not happen at scale, not even for civilizations vastly older than ours? The universe may be full of life that stayed home. Intelligent species that looked up at the stars, did the same physics we did, concluded that the cost-benefit ratio of interstellar expansion is prohibitive and turned their attention inward instead, to managing their own biosphere, to building incredibly rich local environments, to whatever a billion-year-old civilization does when it decides that crossing the void is not worth it. And here's the interesting thing about that hypothesis. It predicts the silence we observe. If most civilizations, once they reach a certain level of technological sophistication, conclude from their own physics that the stars are too expensive to reach, then the galaxy would look exactly like what we see, empty, quiet, with no megastructures, no signals, no probes showing up in our solar system. Not because life is rare, but because gravity and the speed of light are universal laws that every civilization in every star system must obey equally, and those laws make the cosmos a very hard place to colonize. Now, I want to be honest about the limits of this argument. It does not prove there are no advanced civilizations. Absence of evidence is not evidence of absence, as they say, and physics allows for possibilities we have not thought of yet. Maybe there are forms of propulsion based on physics we do not yet understand. General relativity does permit solutions to Einstein's equations, where space itself is warped in ways that could, in principle, move a ship faster than light without violating local causality. The Alcubierre metric is the famous example. But the energy requirements to do this, as calculated by physicists, involve negative energy in amounts that make the entire mass energy of the observable universe look small. Gravity, again, is the enforcer here. It does not bend easily. What I find genuinely exciting about all of this is not the pessimistic interpretation, but the clarifying one. Gravity is not just a force that keeps your feet on the ground. It is a universal constraint that shapes what is possible for any physical being anywhere in the cosmos. The same equations that Galileo started working out by rolling balls down ramps, that Newton organized into a single breathtaking framework, that Einstein then revealed as the geometry of curved space-time, those same equations put hard limits on what intelligence anywhere in the universe can accomplish at large scales. We're not alone in facing those limits. Every civilization that ever existed or ever will exist is bound by the same physics. And that thought, to me, is one of the most profound things physics tells us. The silence out there is not necessarily a sign that we are special or unique or alone. It may simply be a sign that gravity is the same everywhere, that light speed is the same everywhere, and that the universe, for all its vast size, has built walls around every neighborhood within it. We look up and see nothing watching us, and maybe the reason is not that the watchers do not exist. Maybe it is that gravity gave them the same lecture it is giving us, and they listened.